let's see the question here. Transitions elements are important metals because of their characteristic properties. So what is their characteristic properties here? So for example, like they show different oxidation states, and then they also have different color. Okay, so these are the characteristic properties. Okay. They form complex ions. Okay. Now, A. Define what is meant by a transitions element. So they expect you to memorize the definition. So I put it here. An element forming one or more stable ions with incomplete d subshell. Okay, now let's see B part 1. So B part 1, for each of the following complexes, state the coordination number and the oxidation number of the transition element present. Okay, so coordination number means how many dative bond. So you can see here, cyano. Cyano, you know, is monodentate. So 2 cyano means 2 dative bond. And then ammonia, or the amine here, amine is monodentate also, 2 of them. So form 2 dative bond. So altogether they form 4 dative bond. 2 plus 2, 4 dative bond, or 4 coordinate bonds. So coordination number is hence 4. So how to find out the oxidation number? So we have to count it in this way. So imagine nickel is unknown, and then cyano is -1, 2 of them. Amine is 0. So overall charge is also 0. So you can see this is the complex with no charge, which cancel off. So by finding X, you will get +2. So that is the oxidation number. Next one, you must write +2. You can't write 2 only. 2 itself is wrong already. Must write +2. Must write plus minus, and make sure your plus minus stay in front, not at the back. Okay. If you write charge, of course you write 2 minus. But if you write oxidation number, you write +2 or -2. Now let's come to the next question. So coordination number again. So you can see this is CrCl2. Cl2 is monodentate. So 2 monodentate. And then H2O is monodentate also, monodentate ligand. So they form 4 coordinate bond. Chlorine, 2 coordinate bond. Altogether 6 coordinate bonds. So coordination number is hence 6. So coordination number means the ligand form how many coordinate bond with the transitions element. Okay, now we want to count the oxidation number of chromium. So let's do it down here. We do Y. Okay, chlorine is minus. So 2 minus 1. H2O is 0. Overall charge is +1. So Y is hence 3. We write +3. So next one, part 2. State the type of bonding that exists between the ligand and the metal ion in these complexes. So type of bond between ligand and metal ion. So that is coordinate bond or dative bond. Okay, so coordinate bond. Part 3, suggest the structures of this complex and name its shapes. You know, nickel, square planar. Nickel platinum, we use square planar. Okay, so square planar. We have cyanide. We have amide. So the shape is square planar. Okay. Part C, the complex ion can be converted into. Okay, you see how they convert. Initially, there is no chlorine, so at the end, the chlorine go in. Okay, suggest a suitable reagents for this conversion. Okay, so anything with chloride lah. Okay, anything with chloride, most probably will make this happen. Okay, so for example, hydrochloric acid. If you write, can I put sodium chloride? Can also. So if chloride is there, this is possible. State the type of reaction. So this is the famous question. Neutralization or ligand exchange. Okay, so imagine you have chlorides that react with this. So chloride go in, H2O come out. So that is ligand exchange. Okay, so ligand exchange. So on the other side, this complex ion shows stereoisomerism. Name this type of stereoisomerism. Okay, so first of all, you see they are having 6 monodentate ligand. 6 monodentate ligand. So in the note just now, right, the octahedra, if you have 3 bidentate, the stereoisomerism shown is optical isomerism. That is what we have in the note. But this is not bidentate, you know. If you see the thing here, H2O is monodentate, chlorine is also monodentate. So this is 6 monodentate. They form cis trans. They form cis trans. So how they form cis trans? You have to break it down to 4 and 2. Okay, so 4 and 2, the 4H2O and the 2 chlorine. Okay, so I write down first. They form cis trans. From here, you will understand that besides square planar, 6 monodentates also form cis trans. 3 bidentate form optical, so need to memorize a bit. So cis trans isomerism. And then they ask you to draw. Draw 3-dimensional diagrams. So how to draw 3-dimensional? So when they say 3-dimensional, your covalent bond must show, show whether it's in out or left right. Have a particular shape like something like this kind of triangle or this kind of this kind of bond and then line, so I have to show something like this lah, okay, to show that whether they are in which direction in 3D. Okay, now let's draw it. So we focus on how to draw cis and how to draw trans. So cis, side by side. Trans is opposite to each other. Cis and trans. Trans is opposite to each other. So my suggestions, you take the one which has two, which is chlorine. Chlorine has two, right? So chlorine, to show trans, we put it up and down, which are opposite from each other. That is trans. So other than that, the rest you do like this. This is to the back. This is to the front. That is the 3D already. Now, all these are the H2O. This is trans. The chlorine is the main focus. They are opposite from each other, so that is trans. Cis, just make them side by side. For example, chlorine, and the rest is H2O. H2O, H2O, O, H2, H2O. Okay, so that is how we do cis trans. And yeah, we settled already these questions.